A sample of a compound contains 0.5860 moles phosphorus and 1.466 moles of oxygen. What is the empirical formula of the compound? A. PO, B. PO4, C. P2O5, or D. P3O4. Here is a general strategy for determining empirical formulas. You can determine empirical formulas if you have enough information to determine the relative numbers of the atoms of different elements in a compound. In other words, if you can get a count-to-count ratio for the atoms of the elements in the compound. Remember that moles are just group counts, so you can also use mole-to-mole ratio. Once you have determined the mole-to-mole ratio, all you have to do is to reduce the ratio to a small whole number ratio. Here's a table that shows how this strategy is implemented. From the question, we note that the compound contains 0.5860 moles of phosphorus and also contains 1.466 moles of oxygen. So the phosphorus to oxygen mole ratio is 0.5860 to 1.466. A good strategy for reducing this ratio to a whole number ratio is to first divide both numbers by the smaller number. In this case, 0.5860 is the smaller number. Dividing 0.5860 by 0.5860 gives us 1.000. And dividing 1.466 by 0.5860 gives us 2.502. Note that we're keeping 4 significant figures in the result because our original numbers have 4 significant figures. So we can see here that 2.502 is almost halfway between two whole numbers. When the decimal point is at least 0.1 away from a whole number, you should not just round it off. What we need to do at this point is to find the smallest whole number multiplier that will make all the numbers close to a whole number. Try 2. If that doesn't work, try 3, and then 4, and so on. Let's try multiplying both numbers by 2. 1.000 times 2 equals 2.000. And 2.502 times 2 equals 5.004. Now we have two numbers that are very close to whole numbers. Therefore, the phosphorus to oxygen ratio is 2 to 5. The empirical formula is P2O5. The correct answer is choice C.